Okay, my friends, it finally happened. New York University put this picture out today, and I'll show you the article, showing the exact same particles that I show. And I can show how they develop and how they split into all of these. The green, the blue, the red, and how these energy levels occur and how they can actually separate. They're showing, and I just sent them this stuff 10 days ago, all of these same particles to take a look at, and I was assured that they would send them to their researchers for them to look at, because I sent a fairly extended note and said these are all the particles. Let me show you what I sent them. I gave them a pretty good explanation of electron flood theory, and which means that protons are made out of nothing but electrons, and electrons are made out of two particles, which are these two. And we showed them in light experiments, actual photons, through a Venturi. So these are the ones that I sent to New York University. And I showed these are the ones that Don Lincoln found at Fermilab and we found here, and that we could split them and create fission and fusion. And then the greens, all right, much more powerful than the reds. And then just a light wave coming through all the particles in space, which is gases that are in the atmosphere, and heat and moisture and all that have electrons attached to them. And this is all the Higgs Fields and so forth, and the particles coming through and accelerating. The blue, the green, the red, the Higgs Fields, showing how the Venturi works. So I claim that they're supporting my evidence by what they just put out today, and here's their article. Okay, they still don't understand it, but they're getting close. This is the dark matter. All right, they're calling them neutrons and protons. It's the black particles are the dark matter, and they surround the white particles until you get concussion, and then you get a separation of the particles, and you get these. You get these, they form those little, just like this. It's exactly what I showed. And I've been showing this for 7 years. This is not new to me. This is new to them. And like I say, this just came out today. I sent them exactly the same stuff 10 days ago. Let's see what they have to say about this. All right, here's what it says here. It's just an artist's rendition. I'm showing you the real thing. The early universe, well, I don't go along with any of that stuff. Protons and neutrons, they're talking about, which are not protons and neutrons. They are just balls of tiny little particles, which are the black and white together, which I call an electron. It's the electron and neutron neutrino in a pair. They don't exist on their own unless you can split them, which is to create sterile muons. That's this X particle they're talking about. So here's the story. It says these proton and neutrons combine to form light elements. Not true. The presence of dark matter, X, changes how much of each element will form. I'm not against that, because the X is the dark matter, and that attaches to the white matter. Now they see it in this form, they see it in that form, they see little tiny balls, they see bigger balls, these are the light forms, and they see them as different colors. These always are the same size. Now I don't know why they're showing different sizes. There's a fixed size, which is the dark matter. Okay, let's go for a Z big picture. This is light, pulse red laser, pip, 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 pip. There's a particle in there which we call a photon that looks just like this, and I will show you these in extreme detail, which have a huge magnetic field around them. So they have a field and a particle. The field creates a wave. The particle sits inside the wave. So it's a particle-wave duality. That's explained. These are pushers and shovers. These pushing hard, these are shoving back. Anytime you have push and shove, you have glow. The more extreme the push, the more extreme the glow, and you don't get much more streamer than that. That is the particle itself, which was in the wave. I said this is particle-wave duality. There's your particle. It's being pulled right out of there. Zip. and it's being sucked through a Venturi. That is the nature of a Venturi, accelerates things. And it did. It pulled that particle. You see the light magnetic field, which is nothing more than a magnetic field surrounding the particle. Now the particle's zip, like shot out of a cannon. It's pulled itself right away, and at this point it becomes extremely excited, and then it breaks apart right here and falls in pieces and then reassembles over here. Fission, fusion, subatomic explosion. And here's the particle itself. Here's the little particle. I'm going to show you how that forms, and then I'm going to show you those other forms that they show in their picture from New York University. Blue is just extremely fast. The red and the green are not quite so fast, but they're pretty damn fast. The green is very fast. The red is slow, actually, compared to the other colors. Now, so let's take a little deeper look, and of course these are the Higgs fields, and this particle here is an unknown particle, and I don't know what to say about it, but I do believe this was a reverse spinner. They're all supposed to spin on the right-hand rule. I think this spin the left hand and dragged its energy into itself, and then when it concussed with another field, it sort of dumped. That's all I can say. So now, don't forget, what we're going to be looking for is these, which I think I've shown you already. Then these happen just prior to this. They start getting real excited, and then they blow up into this. And then they even get more excited than this, and they have spikes coming out. They don't sit on their sides like that. They sit straight up and down to the pole of the Earth. This is the dark matter, which is the black ball that will be attached to the glowy balls. They can go on their own, called sterile muons. The other particles are the white glowy particles. They come back together and they reform themselves into photons and then back into just unseen particles, which I will show you. And at the same time, Higgs fields show up all over the place. All right, once again, I've shown this to CERN, I've shown this to everybody, Fermilab, University of Geneva, everyone. These are the same particles Don Lincoln saw in 2013. The black fixed particle never changes size, and the glowy little white one, it can get big and small, and it can squirt right through our Venturi. Single slit, not a double slit. So these are the particles I just showed you, and you can see them very easily in the drawing that they did, showing these same particles. And what else do they show? They show those particles coming apart, which is the black one. I said in their thing, I think it's a green one, but it's a sterile muon, which is this right here. It comes unattached from the white particles. You see how the black ones are attached? And each one of these is a bar magnet. That's all it is. It's literally, that's all it is. And they're tiny, tiny, tiny. And they're the size of electrons. So half of this is an electron. The other half is an electron. Glued together, they are a photon. Photons will bounce off of you. Electrons will burn into you. That's why static and lightning and electricity burns you. Extreme light normally will bounce off. It'll warm you up, but it's not going to roast you like it would be electricity and sparking and fuming and destructing. Now, what is this? The muon is the black ball. They wanted to see sterile muons, which I showed you. We're going to go back and look at them again. I'm not going to let you off the hook easy here. Now, we also see electron showers. And those came from that white ball. So the black and white were attached together here. Now they separate. That's fusion. I mean fission. Anything that separates is fission. And they were together. We saw them. They were right there. And I'm going to show them again as they develop. And then you're going to see that little Oreo cookie looking thing. Coming through here, they divide and then they shatter away from each other, and then they re-grab the black ones. The black ones never change size. Same size here as they are here. They are a fixed particle, precisely as Don Lincoln at Fermilab claimed. I agree. Fixed, squishy. And this I did 7 years ago, and the video title of this was "Light is Dark Energy While Traveling from the Sun to the Earth." That was 7 years ago, and I haven't had anybody willing to step up. Now they're finally admitting it because they refitted CERN, Large Hadron Collider, and they even reworked Fermilab stuff so that they could focus. I said, you have to focus. I went to the University of Geneva. I said, you have to focus, or you're just hitting things just accidentally. And then they shut down. They went 3 years. They made them focus. I don't know if it's because of what I said, but I showed them all this stuff too. And they were intrigued. They did not shut me down. They just went on their way. And the next thing I know, they're doing the same thing we're doing and getting tetravolts, which is trillions of electron volts instead of hundreds of thousands or millions. They're getting trillions now. And immediately, as soon as they put it back together, focusing, boop, it's coming off the... And everybody's, you look, you're going to see all new physics everywhere. But everybody wants to take credit for it. All right, check this out. These are all the particles together. I showed you the 2-point particles and the fixed particle and our photons and muons, electron neutrinos, electron showers. Well, in order to get to the point where you get to the Venturi, to really get that extreme explosion, you go through this phase right here. You see this? This is the Oreo cookie. And then as it gets closer to the Venturi's down here. The light is coming this way. All right, light goes pretty fast. Here, you see that little glowy particle between two little black particles. To me, I call that the Oreo cookie phase. And then, as it starts to stack up at the Venturi, dust there, at the Venturi, it starts to display this configuration, and then it literally explodes into its component parts, the blacks and the whites, at the Venturi. So it gets the cookie, the box, extreme spiky box, explosion. Let me show you the green. You can see it a little better how, well, you might be able to see some spikes. Yeah, you can see the spikes on that. It's not too bad. Back here you don't see spikes yet. You're just getting barely ready to get spiky. Now she's getting spiky, and now she's exploded. Bada bing. Case is closed for that one. So, and it comes right back together almost instantly. Now, let me show you what the green looks like, because the green is exactly the same, so is the blue. All photons are these little boxes of particles. And then as they get bigger and bigger and bigger, they become more and more destructive. These are photons. They'll bounce off you. They shouldn't really hurt you unless there's just such extreme focus to them. Then they will hurt you, I would imagine. But I can't even be sure of that. Alright, this is beyond cool. I'm showing every single thing right here in what they show here. These are the Oreo cookie phase, which is here. I'll show that close up in a second. And then you've got the divided phase, which is just a black ball sitting on its own, which is the muon, sterile muon. And then you've got the four-banger here, which is this photon. And it's all the same particles, exactly the same particles. Now, remember this Oreo cookie phase. Here's what it looks like up close and personal. As the light starts to come in, it starts to accelerate and starts to glow, which is what whoever that was, New York University, showed. This phase right here is the Oreo cookie phase, where it's glowy in the center and dark on the outsides. Then it starts to stack up, and you get this, and you get a box formation. Then as it gets glowier, it's more glowy because it's ready to impact, you actually get spikes up and down. It's going to be hard for you to see that, but they are there. Alright, now, what happens next? It hits the Venturi, and at the Venturi, it's kaboom, and they fall apart. The black separates from the white. Now, green is much faster, and it's displaying the exact particle nature of what a photon is, and then it's getting ready to flip. Okay, they charge up and then they flip. I think I showed this, or I will on the red one. And then they look like this really close up. So, and this one has the spikes. That's just getting ready to to divide. And these do divide too. The black and the white divide. It's a little less control with the green because it's so energetic. The red we can control pretty good. Now, I don't know if they have a lot of difference in energy. When they turn into muons, they may all have the same energy at muons, but I don't know. I think a muon from a red is not as powerful as a muon from a green, and I'll show you why I think that may be true. Now, there is a huge difference in the concussive value of red versus green. Green is extremely powerful, and it reconcusses way out here. So it's highly energetic compared to the red. Now, when they divide though, and they turn into the muon and electron shower, are they all the same value at that point? I don't know. All right, there's different powers. The green, the red, and the blue are all different powers, but they all have a black particle and then they have a white particle attached. When they divide, do they all have the same energy? I don't know, but I can tell you what right now, there's not a taste of black in here. 100% white. So the black is completely separated. And if we can get right in here, there should be a lot of energy here. And you can see it just visually that it's an enormous increase in energy. Just for one last look. The normal wave coming through the air just like normal, being very quiet basically. All of a sudden accelerating like a rocket ship, exploding here. The enormous energy here, it's absolutely staggering. And the reverse concussive waves are just absolutely amazing. That's because of this literal explosion. This is a subatomic nuclear bomb. And it's going boom. And all of these reverse concussions are just like shock waves going out all through the micro universe here. Now, once again, the green, very energetic compared to the red. However, what we did do is the way this venturi was constructed was offset. So the blacks all went to this side. See black particles all over the place? And a lot of white went with it. But this side, no black at all. So we've obviously been able to at least corral most of the, or I would say all the black this way. And there's none this way. It's just all green. And the green is very, very energetic. And look at how far out it's coming out here. And it's still no real Higgs fields yet. Every one of these sprits will eventually turn into a Higgs. When they're very close to the origination point, the Higgs come in pretty quick. Let me just show you on the red and make it a little more understandable. All right. When Rod did these shots, he took pictures straight down. He took from the side, from the front, from every different angle. This is going straight down. This is the light accelerating. This is the explosion. These black particles are the muon neutrinos, sterile at this point because they're no longer attached to the white. The white squirts through here as electron showers, and then it recombines back over here. This is the entire event. Now, when I say Higgs fields show up way out here, but they also show up way down here. Let me show you a close-up of this and why they show up here. As soon as the white can get enough away from each other to sort of settle in a little bit, it will start grabbing onto these black particles to reform, because that's gravity and dark matter. Alright, so here's CERN, or Fermilab. This is the muon neutrino, the black ball, and this is the electron neutrino, the white ball. And then it turns into a shower. Here's where they separated right here. Alright, that's fission. They broke apart. Now, as they go through the venturi, not a taste of black, not even a taste. Well, look what happened right here. These blacks are showing back up again. What are they doing here just all by themselves? Where'd they come from? I think they're in space, just waiting around to reattach. This looks like to me. I don't think they jumped ahead of here and just grabbed on. So otherwise they would have to rob these black ones from somebody else's black ones. I think there's extra black ones laying around. That's just my guess at this point. But they came through here and they started to attach here. And whenever you see the black reattaching to the white, these are the Higgs fields. And you see all of a sudden they start coming out here, the Higgs, 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 Higgs. Well, you don't see them as Higgs right here. but you will looking into it. You'll see them as the Higgs just exploding right at this farther out distance. And you'll see white. Here, it's already attached. So when you look down into this Venturi, you're going to see Higgs way, way, way down here, and then you'll see them way out here. And it'll look kind of strange. It took me a long time to figure out why. But they are already attaching instantaneously. I mean instantaneously after the Venturi. Right there, boom. You're not even a bazillionth of an inch away. Now, let's look at a little different shot here. Okay, this one really had me confused. This took some while. You see that little spritz there? All those little white sprays. Well, why are they like that? Because they are that white zone, and then all of a sudden they smack into particles that they start to recombine with and spin. Now, way back here, remember I showed you the black balls were right after the Venturi. They were just sort of hanging right around the edge. That's why we're seeing these Higgs fields way back here, behind the spray of white coming out at us. These are the ones that are concussing at the edge of the white glowiness. All right, because there'll be a certain distance out where they just can't maintain that much energy anymore, and boom, they lock into particles that are in the field. All right, I think I can leave it at this. This is the muon. This is the electron showers. That's the sterile muon. That is supposed to give you trillions of electron volts. We should absolutely be able to harvest energy here. Shown this another million zillion times. This is nothing more than taking our focused energy and putting a harvester here. And there's all kinds of new harvest devices that they're coming out with now, because solar energy is the way to go. And this is nothing more than solar on steroids. Now, out here, remember I showed you where they reconcuss? That's fusion. But right around the edges, they keep getting into each other, because as soon as the white is far enough apart, it loses all of its, just absolutely hates to be around each other. That's why white will always coat the black. The black doesn't mind. See the black ones right on top of each other. Couldn't care less. No problem. Yeah, come on over here. We'll just hang around together, have a good time. White ones, get away from me. And that's how you end up with these interference. It's not interference because one's flapping this way, one's flapping that way. This is a single slit. Interference is push to shove. See, there's a little better shot of it. They're breaking apart, they're coming back together. They never drifted, the same size here as they were there. No change in the black ones. I agree with CERN. What happens here? These guys say, you stay away from me. I said, yeah, I'll stay away, you stay away from me. It's okay, no deal, no problem. And they spin on their own little line to keep those guys away, and they keep those guys away. These are called interference. They're push to shove patterns. They're repulsion patterns. Now, most of them are going through the center, and they cannot get away from each other because they're blended together. And you're getting all these blacks are trying to jump in. Blacks are going to try to jump right in as fast as they can get into a free spot, like this edge. They come in the edges. You see them all through the edges. Wherever they can get an edge, they come back and attach. All these are edges. All right, I think I'm starting to fully understand this. And this energy value is absolutely unbelievable. They say trillions of electron volts. And if anything is even close to what I'm saying, all this stuff is on the shelf right now. We should be able to be using these in a couple of weeks if somebody would just take a good interest in this.